In further mathematics, we often sketch rational functions before solving inequalities. A rational function with a quadratic denominator has vertical asymptotes exactly where that denominator equals 0. In symbols, if f of x equals p of x divided by q of x, the vertical asymptotes occur where q of x equals 0. Now for our worked example, let f of x equal 1 divided by the quantity x squared minus x minus 2. First we factor the denominator. In plain words, we look for two numbers that multiply to give -2 and add to give -1. Those numbers are -2 and 1, so the denominator factors as x minus 2 times x plus 1. Setting the first factor equal to 0, x minus 2 equals 0 gives x equals 2. So there is a vertical asymptote at x equals 2. Setting the second factor equal to 0, x plus 1 equals 0 gives x equals -1. So there is a second vertical asymptote at x equals -1. Next, we look for turning points by differentiating f of x. Using the chain rule, the derivative of f of x equals negative the quantity 2x minus 1 divided by the quantity x squared minus x minus 2 squared. A turning point occurs where this derivative equals 0, which happens when the numerator is 0. Setting 2x minus 1 equal to 0 gives x equals 1/2. Substituting x equals 1/2 back into the denominator, we get 1/4 minus 1/2 minus 2, which simplifies to -9/4. So f of 1/2 equals 1 divided by -9/4, which equals -4/9. This point sits between the two vertical asymptotes, and the curve dips down to -infinity on both sides of it. So this turning point at x equals 1/2, y equals -4/9 must be a local maximum. Now we can sketch the curve using this information. On the left of x equals -1, the curve rises from just above 0 and shoots up toward positive infinity. Between x equals -1 and x equals 2, the curve falls from -infinity, rises to the local maximum at -4/9, then falls back down to -infinity. To the right of x equals 2, the curve falls from positive infinity down towards 0. This gives us the complete two-dimensional sketch, with three separate branches divided by the two vertical asymptotes. To see this more vividly, picture the same curve lifted into 3 dimensions. We add a z-axis and draw the curve as a wire sitting in the xy plane. The two vertical asymptotes now appear as flat vertical walls, showing exactly why the curve can never cross them. Now let's solve an inequality using this same function. We want to solve f of x is greater than or equal to 0, that is 1 divided by the quantity x squared minus x minus 2 is greater than or equal to 0. The numerator is always exactly 1, which is positive, so the fraction is greater than or equal to 0 exactly when the denominator is greater than 0. Notice the fraction itself can never equal 0 because the numerator 1 never equals 0. So really we are solving the quantity x minus 2 times the quantity x plus 1 is strictly greater than 0. We use a sign diagram with the two critical values, -1 and 2, splitting the number line into 3 regions. In the first region, x less than -1, we pick a test value, x equals -2. Substituting x minus 2 times x plus 1 equals -4 times -1, which equals +4, so this region is positive. In the second region, between -1 and 2, we pick a test value, x equals 0. Substituting x minus 2 times x plus 1 equals -2 times +1, which equals -2, so this region is negative. In the third region, x greater than 2, we pick a test value, x equals 3. Substituting x minus 2 times x plus 1 equals +1 times +4, which equals +4, so this region is positive. Since we need the product to be strictly greater than 0, the solution is the two positive regions, that is, x less than -1 or x greater than 2. For our check step, we test one value from each region directly in the original function. At x equals -2, f of x equals 1 divided by 4, which is positive, matching the positive region. At x equals 0, f of x equals 1 divided by -2, which is negative, matching the middle region. At x equals 3, f of x equals 1 divided by 4, which is positive, matching the final region. Every test value agrees with both our sign diagram and our sketch. This confirms the solution x less than -1 or x greater than 2